Welcome to Student, a series of animated calculus videos that will help you prepare for the AP exam. These videos were made by students for students.
Hi, welcome. Today we are going to be talking about the topic determining limits using algebraic manipulation. Now the key portion of this unit will be the algebraic manipulation. There are multiple ways to go about determining limits, whether it be using graphs or a L'Hopital's rule, but we are going to do it algebraically, which I'm going to show you. So, let's practice. We are going to be using a problem from the AP Calculus 2008 multiple choice exam, and our problem is the limit as x approaches 0 of 5x to the 4th plus 8x squared all over 3x to the 4th minus 16x squared. Now it is very important that you understand in order to determine a limit algebraically, the problem will have to end up being 0 over 0. You must always test this out, which I will show you how, but algebraically it must end up being 0 over 0. If it is not, if there is some sort of constant that is not 0 in your equation, that will be your answer. In this case, if it is 0 over 0 in any situation, it is very important that you don't automatically go to 0 or non-existent. We are going to change the equation algebraically in order to get our answer. It may end up being 0 in the end of our algebra changes, but from the beginning, do not automatically go with 0 or non-existent. So let me show you how to do this. So here is our problem. We are going to split up our paper and have steps on the right side. So our first step in any situation is to plug in x. So there are our x's. By plugging in the 0, we end up with 0 over 0, as I said. If it is constant, that will be your answer. However, in this situation, we are going to change it algebraically. You can do this in multiple ways. You can use L'Hopital's rule in chapter 4.7. There is somebody who will teach you how to do that. I am going to teach you how to do it algebraically. So what do I mean by this? In this specific problem, we're going to factor. Now we can take out those x's and cancel them out in order to simplify this equation. It is very important that you don't drop your limit until you actually apply the x into the equation. So we're going to end up with limit as x approaches 0 of x squared times the quantity 5x squared plus 8 all over x squared times the quantity of 3x squared minus 16. So we're going to reduce. We're going to cancel out those x squareds, and we're left with limit x approaching 0 of 5x squared plus 8 all over 3x squared minus 16. So now that there's nothing else we can do, we can plug our x back in. You may now drop your limit because you are applying that 0. So by involving that 0 in the equation, we are left with 8 over 16. By simplifying that, we are left with negative 1/2, being A. Alright, so now we are going to try another problem. So I got this example from the dummies.com website. It is, as the limit of x approaches 0, 1 over x plus 6 minus 1 over 6 all over 6. Our answer choices are 0, 6 over 25, 4, negative 1 over 36, or non-existent. As I said before, it should not be 0, and it should not be non-existent, at least not from the beginning. So please if you take anything away from this, take this away. Do not automatically choose 0 or non-existent with a 0 over 0 equation. So here's our equation. We'll split up our paper, and step 1, plug in x in any limit. So we're going to plug in that 0, and we're going to get 0 over 0. Do not choose 0. Do not choose undefined, non-existent, any of those. So we're going to solve this algebraically. So our step 2, we're going to find the LCD of the top fractions, meaning we're pretty much going to simplify it. In any limit, you just try and look for any way to simplify the equation as much as you can. So we're going to take, this is our equation, just kind of spread out a little bit, and we're going to separate them. So we're going to multiply by the common denominator. So we're going to multiply the 1 over x plus 6 by the 6, and we're going to multiply the negative 1 over 6 by x plus 6 on the top and bottom. So by doing so, we're going to simplify it, and we're going to get limit as x approaches 0 of 6 over 6 times the quantity x plus 6 minus x plus 6 over 6 times the quantity x plus 6 all over x. So now we have a common denominator on the top fraction. Because of this, we are now able to combine the top fractions. So we are left with the limit as x approaches 0 of 6 minus x minus 6 over 6 times the quantity of x plus 6 all over x. So we can simplify even further. So we're going to get rid of those 6's, and we're left with the limit as x approaches 0 of negative x over 6 times x plus 6 all over x. We can simplify even more by getting rid of that x on the bottom and multiplying by a 1 over x. By doing so, those x's cancel, and we are left with a negative 1 on top. So we have the limit as x approaches 0 of negative 1 over 6 times the quantity of x plus 6. Now, our final step, because we can't simplify any more, we can plug that x in. So we can drop our limit, and we are left with negative 1 of 6 times the quantity of 0 plus 6, which gives us our answer of negative 1 over 36, being